Alright, so in this video we'll take a quick look at measures of center and spread, try to kind of start to really get a better feel for what the data is really trying to tell us. The two main measures of center, we've talked about them in here, but here's some better, I guess, definitions, if you will. So the median, one of the big measures of center that gets used a lot throughout this course, and that is essentially the exact middle set of the exact middle of a set of data, excuse me. So that's where we can kind of count in from the endpoints and work our way back to the median. The other one would be the mean. And the mean is something that most of us are pretty familiar with, which is just the arithmetic average. So you also hear the mean slash average kind of used interchangeably. And that's something we can calculate by hand. But we have this calculator, you run that one of our stats, and it comes up with the median and the mean very, very quickly. Another way to look at the mean is as a balancing point for the data. Right, so some of our data sets, are kind of symmetrical like that, so kind of the balancing point would be here. But let's say we have a really skewed data set. Maybe we have to put that balancing point a little bit further out. In terms of notation, the big thing that we want to make sure that we're taking from here is this idea, this right here, x bar. That's what we're going to use as our notation for mean from now on. So anytime you see x bar, go ahead and realize they're talking about the average. On top of the average, it's just the summation of your observations divided by the total number of observations. So this is one of the ideas that's pretty central to mean versus median, is the idea of a resistant measure. So something is resistant if it's not easily influenced. That doesn't mean that it's not influenced, but it's just not easily influenced by extreme observations. So the question for us, is the median a resistant measure? So you think if you had a data set, 1, 2, 3. Well, the median of that data set equals 2. And then the mean, x bar, 1 plus 2 plus 3, is 6 divided by 3. There it is. So let's say that we put an extreme observation in there. Right? We'll add, something like 12. Well, the median doesn't shift very much. Now all of a sudden, the new median is about 2.5. But as you can tell, if we threw a 12 in there, all of a sudden we got 1 plus 2, 6 plus 12, you got 18 divided by 4. So now my new mean, 18 divided by 4 is 4.5. So it got shifted quite a bit, as opposed to the median, which just shifted a little bit. So this idea of resistance, a median, as you can see from this one example with these 4 numbers, is a resistant measure versus the mean is not a resistant measure. So with that in mind, sometimes on the news, people can kind of go back and forth with whether or not they'd report the median or the mean, right? So you start thinking about some of the data sets that might be severely skewed. Maybe like salaries at a company, where the CEO makes a lot more than everyone else. Well, that could definitely affect the average very, very quickly. And so depending upon maybe what you would want to present, maybe you're trying to bring in new employees, so you could use an average job salary versus median, where the median would probably be a little bit lower because the CEO's salary wouldn't be included or wouldn't have as big of an influence on it. So other places you hear like median home price for a neighborhood versus average home price. Again, you start to kind of think through, different people would present different information depending upon what they want their viewers and their listeners and their readers to see or hear. All right, so measures of spread. Two of them that we've already talked about. IQR, just right, Q3 minus Q1. And what that gives you, it kind of gives you the spread of the middle of the data. You get a real good look at that with your box plots. Range, right, just max minus min. It gives you a pretty good look at the overall spread of the data. But one of the most important measures of center that we're going to talk about in this course, and we use throughout the course from today until we're done with this course, is what's called standard deviation. And we can start that conversation about standard deviation with the idea of what is deviation. So in general, right, deviation is just how far something is away from the typical value. So for us in this class, a deviation would be the distance something is from the mean. So in other words, we take our observation, x sub I, and we subtract the mean. So let's say that some task, we do a study, and this is 4 different people. It took one person 1 minute, one person 3 minutes, one person 7 minutes, one person 9 minutes. So the average of those, if we add them up, 1 plus 3 plus 5 plus, or 1 plus 3 plus 7 plus 9 divided by 4 is 5. So the deviation, right, you think about it, how far is 1 from 5? Well, it's 4 below, hence why it's negative 4, right? And then you go, well, how far is 3 from 5? It's 2 below. And then you go 7, which is 2 above, hence it's positive 2, and then 9 is 4 above. If we want to start thinking about standardizing these deviations, what we're really looking at, if you want a nice confusing set of words here, but you really start to kind of think through it, really what standard deviation, it's the average distance an observation is from the mean. Right? And so to take an average, if you take an average, we're going to have to add all those things up. Well, if you take a moment, you think about this, negative 4 plus negative 2 plus 2 plus 4, well, that's 0. And if we try to then average that distance, we have 0 divided by 4, which wouldn't tell us anything because obviously the average distance of each of these values from 5 is not 0. So what we need to do is kind of play a math trick, and that trick is going to involve what's called a variance. And what that does is we're going to take all of those deviations and square them. So in other words, here's a notation. One of the things to notice is this n minus 1. That kind of becomes clear, or more and more clear, as the course progresses. So right now you're just going to have to kind of take my word for it. So we have our deviations from the previous page, negative 4, negative 2, 2, and 4. First step, just square all of those, and all of a sudden now we have 4 positive numbers, right? So what this tells us to do is go ahead and sum those up, right? So 16 plus 4 plus 4 plus 16 is 40, and then we'll do 40 over 4 minus 1, right? This again, you're going to take my word for it now. It comes into a little bit more focus, and you get a little bit more clarity on that when the course, as the course progresses. So right now, we know the variance is 13.33. So we take a step back. Our original unit of data was a minute. Well, when we squared everything, our units became minutes squared. So that kind of begs the question, well, what does a minute squared mean? What does that really measure? And the answer to that is nothing. It doesn't tell us anything. So right now, our variance is 13.33 minutes squared, which is useless. So for us, what we have to do, we need to convert this, we need to get back to minutes. And how do you get from squared to nothing? That's just go ahead and take the square root. So for us, you take that 13.33 and take the square root. So like I said before, what standard deviation does, it basically gives you the average distance from the average. And one of the big things to realize, we only use it if the mean is chosen, because standard deviation is reliant on the mean. Something to think about, when would the standard deviation be 0? When would the average distance from the mean be 0? Well, really what you're looking at there is if your data set was all the same numbers, right? The mean there would be 5 and everything 0 away from 5. And one other question to consider, is it a resistant measure? So what we know right now is that the mean, right, x bar is not resistant, and since we're using x bar to calculate the standard deviation, then it's definitely not a resistant measure.